In the realm of scientific exploration, researchers seek tools to match their curiosity. Enter Julia, a high-performance language for numerical and scientific computing. Julia navigates mathematical computations with speed and agility. Its JIT compilation achieves performance like C and Fortran. Julia executes code at lightning-fast speeds, ideal for simulations and machine learning. Imagine witnessing a supernova powered by Julia's computational prowess. Julia's intuitive syntax makes it easy to learn and use. This allows scientists to focus on their research, not the programming language. Julia empowers researchers to push the boundaries of human knowledge. Julia excels in scientific computing due to its speed, ease of use, and ability to handle complex mathematical computations. Imagine a universe governed by intricate equations. Julia effortlessly solves these with precision. Its multiple dispatch system allows functions to adapt based on argument types, crucial for varied data. Julia's built-in support for parallel and distributed computing handles massive datasets seamlessly. It's like having a supercomputer at your fingertips, processing vast amounts of information effortlessly. Julia's impact extends far beyond the realm of academic research, reaching into the heart of various industries, transforming the way we approach complex problems. In finance, where milliseconds can mean the difference between profit and loss, Julia's speed and efficiency make it ideal for high-frequency trading algorithms and risk management models. Imagine a stock market where trades occur at lightning speed, guided by the precision and accuracy of Julia's algorithms. In academia, Julia is empowering researchers to tackle some of the most pressing challenges facing humanity. From modeling the spread of infectious diseases to simulating the effects of climate change, Julia is providing scientists with the tools they need to understand and address these complex issues. It's like having a virtual laboratory at your disposal, capable of running countless simulations and experiments with unparalleled speed and accuracy. In engineering, Julia is being used to design everything from more efficient wind turbines to safer self-driving cars. Its ability to handle complex mathematical models makes it an ideal tool for optimizing designs and ensuring safety and reliability. Imagine a world where bridges are built to withstand the test of time, where airplanes soar through the skies with unparalleled efficiency, all thanks to the power of Julia's computational prowess. While traditional tools like MATLAB and Python have long dominated the landscape of scientific computing, Julia's arrival has ushered in a new paradigm, challenging the status quo and offering a glimpse into the future of the field. It's like witnessing the dawn of a new era, where the old ways of doing things are being replaced by something faster, more efficient, and infinitely more powerful. MATLAB, with its user-friendly interface and extensive library of toolboxes, has been a staple in academia and industry for decades. However, its reliance on interpreted code can lead to performance bottlenecks, especially when dealing with large datasets or complex computations. Python, on the other hand, has gained immense popularity due to its versatility and vast ecosystem of libraries, particularly in the field of data science. However, its dynamically typed nature can sometimes hinder performance, especially in computationally intensive tasks. Julia, with its unique combination of speed, ease of use, and a rapidly growing ecosystem of packages, offers a compelling alternative to these established players. It's like a hybrid vehicle, combining the best of both worlds. The speed and efficiency of a sports car with the versatility and practicality of an SUV.